Hi guys, so in today's video we are going to talk about solving equations. We're going to take a look at three types. We will look at two-step equations, multi-step equations, and equations with parentheses. So let's get into the first group of examples. We'll start with number 1 in the red section. It says negative 11b plus 7 equals 40. So to begin, as a quick reminder, the purpose when we solve any equation is to get the variable alone, isolated, right? That means anything that's with the variable has to be eliminated, moved to the other side, that kind of thing. So our variable this time is b. We can see there's a negative 11 with it and also a 7. And when I say with, I mean on the same side of the equal sign, okay? So I'm not concerned about 40 because 40 is not with b because it's on the other side of the equal sign. So the only items we need to move away from b are negative 11 and 7. So the point is now, which one do we move first? So way back you learned order of operations, PEMDAS, please excuse my dear Aunt Sally, or some sort of way to remember the order in which we do math problems. Well, when we're solving equations, we do the complete opposite. We just do the opposite of order of operations, okay? So if we put it up here, just kind of as a reminder, we have PEM, DAS. Normally we would start with parentheses. We're going to go in the opposite direction and start with addition and subtraction. Okay, so we would actually need to get rid of the 7 first because that's a part of this addition and subtraction. And we do the opposite. Solving equations is opposite everything. So we'll subtract 7 on both sides because we do need to be fair. Both sides of what? Both sides of the equal sign. 40 minus 7, 33. Bring it down to equals, bringing down everything else. Why did I do that? Because I knew 7 minus 7 was going to cancel. That was the whole point. Not going so slow through that because you guys have already done one-step equations and you know it. So not going to harp on that too much there. So at this point, we just keep continuing on. We need b to be alone. There's a negative 11 there that's right beside it that's being multiplied. So to undo that, we need to divide by negative 11 on both sides of the equation. Okay, so the 11s cancel. Of course they do. That was the whole purpose of us choosing to do that. And b equals negative 3. Or so our scratch word tells us. I suggest every person solving equations, if you have time, to go back and prove to yourself that the solution is right. You don't have to wait for a teacher to correct you, for a test to score you and tell you if something is right or wrong. You can know for yourself and make adjustments if necessary. So I'm going to show you how to check your work, simply substituting your solution back into the original problem. Okay, so negative 11, instead of b as a variable, we think b is negative 3. So let's replace it. Plus 7, and we think, we hope, that equals 40. So now I'm just going to check and see if the left side actually matches the right. And this time you do use your standard order of operations to solve it. Negative 11 times negative 3 is positive 33. Plus 7, does that equal 40? 33 plus 7 is 40. And of course 40 is 40. So yes, our answer here, b equals negative 3, is correct. Let's move on to question 2 in our yellow grid. We have negative 30 equals 5 times the entire sum, x plus 1, that's in parentheses. Now we can tackle this problem in multiple ways. I'm actually going to show you two. You can choose which way is better for you. A lot of times when people see parentheses and a number on the outside, they immediately jump to distributive property. So let's do that way first. This is method number 1. Distributive property tells me to multiply the 5 by everything in the inside. So that would give us 5x, and 5 times 1 would be 5. Still equal to negative 30. And now we have an equation that looks like number 1, where we have a variable, x, and we have 2 things on the same side of the equation with it. So we need to get rid of these 2 5s. The positive 5 at the back we need to get rid of first if we're following reverse order of operations. So I like to draw a line to separate my 2 sides of my equation. That line goes through the equal sign. We subtract 5 on both sides. Of course, 5 minus 5 cancels, but you knew that was going to happen. That was why you chose to do it. So we end up with 5x equals negative 30 minus 5 is negative 35. We know that from our practice with adding and subtracting integers. So you know that. So negative 35 equals 5x. Just divide both sides by 5 now, we'll be done. And we believe x is negative 7. Okay, I'm just going to hold that right there. We're not going to check it until after we do method 2. Okay, let me change colors, and that might be a little bit glaring to the eye. Let's see. So method number 2. This time, instead of distributing that 5 through, let's start with identifying the variable that we've been doing. Right? So x is a variable. And let's say we need to get rid of this 5 and this 1. All right. So remember, it's reverse order of operations, but we have the x plus 1 in a grouping. So that 5 has to be moved first because it's outside of the grouping before we can get to the inside and take care of the 1. Okay. The 5, of course, was multiplication. So to undo it, we divide. Okay. Divide what? Divide both sides of the equation by 5. So those cancel. Negative 30 divided by 5 is negative 6 equals x plus 1. And then you just want to get rid of the 1 that's there. It's positive, so you would be subtracting. Remember, we do the opposite of everything. 1's cancel. X equals negative 7. You got the same thing, no matter which method you did it. So let's hope, right, that this is the right answer. We can substitute the negative 7 in. I don't have a lot of room, so we're going to kind of do a lot of this mentally. Negative 7 plus 1, you know that will turn into a negative 6. So we rewrite that as a big negative 6. 5 times negative 6 is negative 30. So it is correct. 2 different ways to solve that problem. Let's keep going on to question 3 in the red grid. It is identical, just about, to question 2. You could use either method. I personally like to divide if I can up front. Division makes things smaller generally. The smaller the numbers, the easier it is for me to do things mentally. So I prefer to divide first if I can. You can do it whichever way you want. Okay? So I'm going to divide both sides by 3. That will leave me with 8 equals n minus 5, and then just simply adding 5 to both sides. Going a little quicker here, 13 equals n. Okay, check your work, substituting back in. 13 minus 5 here gives me 8. 3 times 8 is 24, so we have that one correct. Number 4, k over 4 plus 3 equals 14. Again, this is one of those ones where we could do this multiple ways. I'm going to show you 2 different methods. Method 1, identifying that the variable is k, need to get rid of the 4 and the 3. Order of operations, the reverse way tells me I need to move the 3 first. So I will subtract 3 on both sides. 14 minus 3 would give us 11. So 11 equals k over 4, because we know those 3's cancel. We know that. And here we have k divided by 4, so the opposite would be to multiply both sides by 4. And when we do that, we end up with k equals 44. We will check that in a moment. Let's take a look at method 2 for this equation. So another thing we could do is get rid of the fraction up front. So I know a lot of times people have anxiety about fractions, but you shouldn't. I have a whole course about fractions to help you conquer that fear. So you can check that out. The link is in the description. But you can eliminate the fractions first if it gives you anxiety to have that fraction in there. How do you do that? How do you change an equation with fractions to not have fractions? Well, what you would do is multiply by a common denominator. Multiply the entire equation by the common denominator. And that's math talk. But in other words, you would multiply it by the number on the bottom of the fraction that works best for the equation. In this particular one, there's only one denominator to pick from. It's just 4. So that's what we're going to multiply by. We're going to multiply by 4. And you multiply the entire equation. You cannot change an equation unless you multiply it by every single item. So we multiply it here, and it turns into a k, which is beautiful. That was the whole point. When you multiply by that denominator, it cancels it. Okay? We'll do some more examples in a little bit, but it cancels it out, and you just get left with k. Now 4 times 3 is 12, and 4 times 14 is 56. And so some people prefer their equations to look like this. Okay? And now we'll just simply subtract both sides by 12, and k is 44 again. Okay? Let's look at question 5. In the red section, we have 6 equals 2 times y plus 2. Again, I'm going to use the method that I prefer. You can do what you want. You can distribute if you like to. I like to divide if it makes sense to. So I can go ahead and divide both sides of the equation by 2. Since 2 does go evenly into 6, that makes sense for me. 3 equals y plus 2. And then we just want to subtract both sides by 2. And y equals 1. It would be our solution. You know how to check yourself now, so go for it and check to make sure that answer is correct. If it's not, let me know in the comments. So number 6, 7n minus 4 equals 31. Just kind of splitting my equation there. We're solving for n. We need to get rid of 7 and the negative 4. Remember, reverse order of operations, we can add 4 to both sides. Remember, whatever you do to one side, you have to do to the other. Otherwise, your equation will not be equal anymore, and it won't be an equation. 31 plus 4 is 35. Next, we need to move the 7. Since it is multiplication, we will divide. And n turns out to be 5. Last but not least, for this section, on two-step equations. And notice it's two-step because all my scratch work only has 2 steps. That's why they call it that. We can literally solve the equation in 2 steps. That's why it's named that. So again, the method I prefer would be to divide both sides by that 7 out front, the -7. Since -7 does go evenly into 42, it makes sense. I get -6 equals z minus 3. I do need to add 3 to both sides. And -6 plus 3 is -3. Again, check behind me, make sure I have these right. And just to remind you guys, before we go into the next section, to get credit for this video as a required assignment, I do need you to comment your first name, last initial, and then just a 3-sentence summary of what you learned in the video. For this next type of equations, we're going to look at equations with variables on both sides. And that just simply means on both sides of the equal sign, the variables can show up, okay? Which means we have a little bit more to do, but the purpose of solving the equation is going to work the same way. So I'm going to draw my line to split the sides. Let's change color so you can see. And I can see here that I have a variable here, here, and here. And I really should have circled the negative with that 2t, but that's all together. So I have the variable occurring 3 times, but on both sides of the equation. Now, before we get into how to get the variable on one side, which is what we need to do, I strongly encourage you to simplify both sides completely before you start moving things across, okay? So that means you need to combine all the like terms you can on each specific side before we start moving things. So let's look at the left side. We have 16 minus 2t, and that's it. Do we have any like terms that we can combine? We have 16 with no variable, just 16, and -2t. We can't put them together, right? Because the 16 does not have the same variable. It doesn't have a variable at all. It can't combine with -2t. So that side is actually okay right now. Now let's look on the right. We have a t and a 4t and a 9. Are there any things that we can combine? Yeah, right. The t and the 4t can go together. So we don't write ones in front because we're highly skilled, but we do know that that's 1t being represented. You got 4 t's right here, 1 t right there. When you combine it, you get 5t. So you have 5t plus 9. What you do not do is make this a 14t. Don't do it. It's incorrect. Don't let me see you do that. That 9 cannot mix with that 5t because it has a t on it. Okay, moving on. Equals 16 minus 2t. Okay, so here is where we actually see some different things happen. You want to put the letters on the side together, right, the variables, and then you want your regular numbers, we call them constants, you want them to be together. It doesn't matter which side you choose, none of that matters. You just have to pick. I want all my t's on this side, all my variables on this side, all my numbers, aka constants, on this side, okay? I'm going to choose to move the -2t to the right, which means I want my t's on the right side. It doesn't matter, it's just what I'm choosing. In order to do that, I follow the same process of doing the opposite. So I will be adding 2t. Okay, Negative 2t plus 2t is going to cancel. I knew that. That's why I did it. 16 equals 7t plus 9. Okay. And now this looks like the same kind of equation we did in the previous section. It's now turned into a two-step. Okay. So we need to subtract 9 on both sides. I'm running out of room, so I'm come up here. 16 minus 9 is 7 equals 7t. Divide both sides by 7 and t equals 1. Okay. You know how to check yourself. It works the same way when you have variables on both sides. Everywhere there is a t, then 1 would need to go if you're going to check yourself. So it would go here, here, and here. And once you substitute in, you just work both sides out. If they equal the same value, your answer is correct. So I will let you do that. Check behind me. Make sure that t does indeed equal 1. Number 2. Again, separating my equation into two sides. I can see there is a d here and a d here. Both sides, okay? Very first thing I want to do is completely simplify both sides of my equation. That means I'm combining all the terms that I can. Well, 2d plus 4, there's nothing to combine. They are not alike, right? 2d plus 4. 4 doesn't have a d attached to it, so can't combine it. Just leave it. On the other side, 10 plus 5d, cannot combine it. Just leave it. So again, we make the choice. We want the d's on one side, the numbers on the other side. I'm going to move 2d again. It does not matter, guys. I intentionally move the small one most of the time because I prefer to work with positive numbers, but it doesn't matter. Some people, they use the method, I want my variable on the left no matter what. I just like to do what's easiest for me, no matter what. So 2d minus 2d, subtract, I get 4 equals 10 plus 3d. Turns into a two-step equation. We continue on. Reverse order of operations tells me to subtract 10. I get negative 6 equals 3d. Divide both sides by 3. Coming over here because I'm out of room. Gives me negative 2 equals d. Check me, let me know if I make mistakes. Send me a message. I'm going to make a mistake on purpose just to see if anybody will catch it. So keep your eyes peeled. Number 3, separating one side, other side, right? I see m here and m here, okay? So it's a signal to me to make sure that my equations are completely simplified on both sides. On the left, I got negative 7, 4m, and 10. Negative 7 and 10 both don't have variables, so we can combine them. You can always add and subtract regular numbers. So negative 7 and 10 becomes positive 3. And now we are ready to put our variables together. Again, move what you want. I'm going to move negative 2m. I do that by adding 2m on both sides. Again, if you missed it, how do I choose what I move? I usually move the smallest one. So out of 4 and negative 2 is obviously smaller. When I choose to move the smaller one, it prevents negative numbers, okay? So 4 plus 2 is 6. It's just, I'm such a positive person. Okay, so here we have turned it into a two-step equation. So it's just like last section, going a little faster here. Subtract 3 from both sides. We get 6m equals 12. One-step equation, you can do m equals 2. Double check me, make sure I didn't make a mistake. Last one. A and A are both completely simplified. They are. No like terms to combine. Let's subtract a on both sides. Those cancel. 15 equals 4 minus 1a. That's one, literally 1a is all that you see. It's 1a. 4 minus 1a is 3a minus 3. Two-step equation here. Add 3. They cancel. We knew that was going to happen. That leaves us with negative 12. Divide by positive 3. And a is negative 4. Check me. Make sure I got that right. Don't forget, comment your first name, last initial, and your 3-sentence summary for credit. We're going to head right on into the next topic. In this last section, we are going to look at equations with parentheses. It is also equations that have variables on both sides, so we're really putting it all together now. For number 1 in the red section, remember we have f on both sides. Just follow the same process, and that process was to simplify both sides of the equation completely. So the left is great, it's just one term, nothing to do, but the right has a little work, okay? So I'm going to erase this so we can see everything. There was a set of parentheses here, and this 7. In this case, because that 5 is sticking right there on the back, we do need to distribute first. We have no choice. There's no like, okay, we'll divide by 7 first. It doesn't do us any good. We need to go ahead and distribute it through. Another reason why I wouldn't use the technique of dividing the equation by 7 is because it's going to create fractions. 11 is not divisible by 7, so we don't want to make something that has nice round whole numbers turn into fractions if we don't have to. So 7 times 1 is 7. 7 times negative 2f is negative 14f. And then this 5 doesn't get multiplied because it was not in the parentheses. So we're just going to simply bring it down and bring down the other side. So we're still working on simplifying the right side. It's not all the way done. Let's combine like terms. 7 and 5 become 12. So 12 minus 14f equals negative 11f. Now we can choose to put our f's on one side together and our numbers on the other. I say let's move the negative 14 over. It is the smallest one, but also we don't want to move the 11 and create an empty slot over there. So let's go ahead and just add 14f to both sides. And that will give us a positive 3f equals 12. Simple one-step equation now. F is 4. Again, check me to make sure that I didn't make a mistake. The F is 4 for question number 1. All right, number 2, splitting my equation. Once again, we do want to simplify both sides of the equation completely. The left is already simplified. Can't combine 4n and negative 8, doesn't work. Over here, let's go ahead and distribute. So 4 times negative 3n is negative 12n, and 4 times 2 is positive 8. Remember, you got to multiply by everything in the parentheses. Bringing down the other side. Now, you can ask yourself, do you have both sides completely simplified? And we do. We can't combine 12n and 8, so we're good. At this point, we want to get variables on one side, numbers on the other, just like we did in the last section. I want us to add 12n to both sides. That will put the variables together. These cancel. I'm left with 8 equals negative 8. Negative 4 plus 12n is also positive 8n. So we got 8s across the board. Two-step equation now. Let's add 8 to both sides. We're going to do the opposite of that negative 8. And now we end up with 8n equals 16. Easy one-step equation, n equals 2. Once again, check me, make sure that I didn't make a mistake here. Number 3 in this section, separating them, we can see there is a b on both sides, and we know we definitely want to get both sides completely simplified. The right side is good to go. We can't combine a 2 and a negative 7b, but the left needs some work. So it looks like question 1, where we had that 5 sticking out there, 3 is sticking out here. That's not something we can worry with right now, but we do want to take this negative 2 and distribute it through the parentheses. Negative 2. Negative 2 times b is negative 2b. And negative 2 times negative 2 is positive 4. So make sure you take that negative through there as well. Don't forget it. And bringing everything else down. Now here, we can still simplify this side. We have a 3 and a 4 that can combine. That will give us 7. The 2b, we just bring it down. So at this point, both sides are finally completely simplified, and we're ready for our variables to be together. Remember, you can choose to move whichever one you want. I am going to choose to move the negative 7. I will add it to both sides. Cancel. And so negative 2 plus 7 would be a 5b, and that's a positive 5b. Don't forget to bring down the 7. So we have 7 plus 5b equals 2. Solving for b, the whole purpose, we do need to get rid of the 7. It's down to a 2-step equation now. So over here, 5b equals negative 5. Divide both sides by 5. b equals negative 1. Check me, check me. Make sure I didn't make a mistake. Last one, and this is going to wrap up this video on equations. Number 4, variables are on each side again. And this time we have a negative that needs to be distributed through the parentheses, or you can say it's a negative 1. Okay, so negative 1 times 4 is negative 4. Negative 1 times h is negative h. Not too bad. And once again, we have the left and right completely simplified. After that happens, after you get both sides completely simplified, then you start moving variables to one side. And it's not completely simplified unless you have one variable each on each side. Right? So you notice how there's one h over here, one h over there. In all of my examples, in both this section and the last one, I didn't start moving them until there was only one on each side. Okay, so let's add h to both sides. H is canceled. Negative 4 equals 3h plus 1 more h. Right? It doesn't have a 1 in front of it, but it's just 1h in front of you. So 3 plus 1 is 4h. Divide both sides by 4, and h is negative 1 as well. Okay. Check that as also to make sure I didn't make a mistake. And that is going to be our video on solving equations, solving two-step, solving equations with variables on both sides, multi-step equations, and solving equations with parentheses. Right? Don't forget to get your credit, comment your first name, last initial, and your 3-sentence summary. All right, guys, see you in class.